Back in this section of chapter 5, we're going to explore a couple of big ideas under the real numbers and their properties. So we're going to really dive deep into some of the key properties that we take for advantage, take for granted. That's the word I'm looking for. That we take for granted. So let's dive into a little bit more. Our key objectives here, of course, are to recognize the subsets of the real numbers and then to recognize the properties of the real numbers. All right. The union of the real numbers is the combination of the rational numbers with the irrational numbers. That connection or that combination or union of sets is what makes up the real numbers. The real numbers have subsets, which we call the rational numbers, and then we have integers, whole numbers, and natural numbers as part of that lower or bigger cycle of sets of real numbers. All right, let's look at an example and try to make some sense of this. So in this example, we're considering the set of numbers -7, -3/4, 0, negative or positive 0.6 repeating, square root of 5, pi 7.3, and square root of 81. So if we were to categorize which numbers belong in which sets, the natural numbers, they only has one element here, because remember the natural numbers are 1, 2, 3, 4, the counting numbers, not including 0. And so the square root of 81 being 9 is the only natural number. In a little bit larger group or set, subset of real numbers is the whole numbers. And this does include 0. So 0 and 9 would be included in this subset. The integers are a little bit bigger than the whole numbers. In fact, it is the union of the natural numbers with their negatives and 0 that make up the integers. And so the integers would include -7, 0, and 9. The rational numbers are everything that can be included in the whole numbers or integers, but also other ratios that are not necessarily integer values. So -7, -3/4, 0, 9, and 0.6 repeating. In fact, we saw in previous example how to convert that back to a decimal value, which was 2/3 in that case. So those are all rational numbers. The irrational numbers are, in this case, the square root of 5 and pi. And finally, then the real numbers would be the entire set. So in this next slide, you'll see what we just said broke down with a little bit more detail. And finally, then we can get into some properties of the real numbers. So here we have the closure property. The closure properties with respect to two different operations. The first one is addition, and the second one is multiplication. Now, these sound really fancy or confusing, but you're very familiar with this. What this is saying is closure under addition means that if you just add two real numbers together, you're going to get another real number. Multiplication is the same thing, but the operation is multiplication. So you take two real numbers and multiply them together, you're always going to get a real number out of it. So that's what the closure property is talking about. And the commutative property means that under that operation, you can switch the order of the elements and still obtain the same result. So commutative property of addition means that if I add A and B together, or I switch it around and add B and A together, you get the same result. And multiplication is the same idea, that if you multiply A and B together, or flip that around and multiply B times A together, you get the same result. So numerically, those make sense. We're very familiar with those. Next, we have associativity under the operations of multiplication and addition. This is a little bit different than the commutativity, which we just talked about. You'll notice something's changing here, but it's not the order. In other words, the elements are A, B, C, A, B, C. But what is different with the associative property is the order in which you combine elements. So on the left-hand side, we're multiplying or adding A and B together first, and then we're either adding or multiplying C, the third element, last on the left-hand side. But on the right-hand side, we're going to add the last two elements first, B and C. We're going to multiply the last two elements, B and C, together first. And then we're going to multiply or add by the first element. And what this is saying is it doesn't matter what order you combine them in using multiplication or addition, that if you, as long as you do them in whatever order, you're going to get the same result. And then next we have the distributive property of multiplication over addition. And what this is saying is that you can add two numbers together and then multiply it by a number, or you could multiply two numbers together, multiply another two numbers together, and then add those, and you would get the same result. And then finally, we have, of course, the zero or what we call the additive identity property. So what does that mean? The identity means that when you act on it with the identity, nothing changes. And so adding 0 to A or adding A to 0 means you're going to get back the value of A and the number A. In other words, adding 0 doesn't change the value. And if we look at, there's the same result for multiplication, but the identity is different. For multiplication, the multiplicative identity is 1. In other words, 1 times the number or a number times 1 is still that number. Okay. And then the inverses come about once we have the identity, then that means then we need a way to get mapped back to the identity. And so how do we, if we add under addition, if we add a number, how do we get back to the identity? Well, we add the additive inverse. In other words, we subtract. So if the number was 5, then how do we get back to 0? We're going to subtract 5 from it or add -5. Likewise, the multiplicative identity, if I multiply a number by 5, then to undo that, I need to divide by 5 or multiply by the reciprocal, 1/5. So for multiplication, the multiplicative inverse is multiplying by the reciprocal, and in addition, it's adding the opposite of the sign of A. Okay, so those are some really important properties, and then let's see how we can identify or play with them. So if we look at this particular example, example 2a, you can see that the order of the two elements are changing, and it's multiplication. So this would be the commutative property because they're changing order. Commutative property is changing order. So it's a commutative property of multiplication. In part B, the operation is addition, and you can see that the elements are in the same order, but the order in which we do the operation changes. And so this would be the associative property under addition. And the third one, letter C here, it's a combination, addition and multiplication. So this one automatically tells you that it's a distributive property. In other words, we can't add 3 and square root of 5 because they're different kinds of numbers, at least not decimally speaking. But we can distribute in by the 2, and we get 2 times 3, and then 2 square roots of 5. So, and then if we were to take a decimal approximation of the irrational number of square root of 5, we could combine these all together, but it would be approximation and not exact. Okay, and then finally, 17 plus the opposite of 17. Well, this is the inverse property. We're getting back to the identity here under addition. So identifying the properties here can help you do and undo problems. This is really helpful for solving and for simplifying and combining terms. Okay, all right. And so that just is a quick journey through the very rich world of real numbers. So I hope that was helpful, and I'll see you in the next video.